This video is on adding and subtracting rational expressions. So in your packet, I am on page 32. So our learning target is going to be I can add and subtract rational expressions. So for this first video, I'm going to focus on just problems 1 through 6 because those all have common denominators. And then for the next video, I'm going to focus on some other problems where they don't have common denominators. All right, so the first question is number 1. All right, so you'll notice that all 3 of these terms have common denominators. So if you have a common denominator, then you can just keep that denominator, but then you do have to take whatever's in the numerator and combine like terms. So I keep the denominator, which is 4y squared, all right, because all 3 have the same denominator, but I combine my terms in the numerators. So 5y and 3y is 8y, and then I have a plus 12 as well. All right, so now that I've combined my like terms, I do have to factor, if I can factor, to see if anything will simplify. All right, so the numerator factors because 8 and 12 are both divisible by 4. So I'm going to factor out of 4, which leaves me with 2y plus 3. And then it's still over 4y squared. But you'll notice that both of those have a 4 in common in the numerator and the denominator. So that 4 would cancel out, leaving me with 2y plus 3 divided by y squared. And if we wanted to think about extraneous solutions, we would say that y could not be 0. All right, so for number 2, we have a common denominator again, which is 3a squared. So I'm going to keep that in the denominator. But now I need to look at what's in the numerator. So I have 9a cubed minus 6a. So 9a cubed minus 6a. Now notice I didn't actually subtract that in terms of operation because they're not like terms. All right, a cubes and a's are not the same. But I do need to factor that. So 3 goes into 9 and 6, and they both also have an a in common. So I'm going to factor out a 3a, which leaves me with 3a squared minus 2 over 3a squared. All right, so now I need to cancel some things out. So here, the 3's cancel, and then a cancels out one of these a's. So instead of a squared, I just have a regular a. So that leaves me with 3a squared minus 2 over a. In the third example, I have a common denominator again, which is 3t minus 12. So the numerator, I'm going to have 2t minus 8. All right. I do need to factor both the numerator and the denominator this time because both of them have a GCF. So in the numerator, I can factor out a 2, which leaves me with t minus 4. In the denominator, I can factor out a 3, which leaves me with t and a minus 4. So the t minus 4s would cancel, leaving me with 2/3. For example 4, this one's a little bit more involved, okay? But we do have a common denominator, which is w squared minus 9. So I'm going to go ahead and keep my denominator. And when I combine terms, none of these combine. So I'm really just making sure that I put them in order. So I do need to factor both the numerator and the denominator. So what can I multiply to get negative 15 that adds together to give me a positive 2? So that would be positive 5 and negative 3. So I'm going to have a w plus 5 and a w minus 3. And then in the denominator, I have difference of squares. all right, because perfect square, subtraction problem. So I'm going to have w plus 3 and w minus 3. So again, the w minus 3's would cancel because they're the same in the numerator and the denominator. And that leaves me with w plus 5 over w plus 3. The extraneous solution would be negative 3 because that would make the denominator 0. All right, but here we're just simplifying, okay? We're not solving anything or anything like that. So we're just simplifying it. For example 5, again, I have a common denominator. So I'm going to keep the a squared minus 4. And then I'm going to have an a squared. I'm going to go in order. So I'm going to have a minus 7a. And a plus 10. So I'm kind of combining my terms, but I'm trying to make sure I go in order. That way I don't have to write down an extra step just to put it in standard form. All right, remember it does need to be in standard form in order for you to factor. So when I factor this, what can I multiply to get 10 that adds together to give me negative 7? Well, 2 times 5 would work, but to be a negative 7, they both have to be negatives. And remember, a negative times a negative is positive 10. The denominator is just difference of squares. So we would have an a plus 2 and an a minus 2. So now we're ready to cancel out. So the a minus 2's cancel, leaving me with a minus 5 over a plus 2. So if we were solving, our extraneous solution would be negative 2. All right, that would make the denominator 0. All right, so then the last example, or at least for this video, we have a common denominator, y squared minus 25. And then here, I'm going to have to do some distribution right here. All right, so I'm going to keep the y squared minus 13 plus 3 minus 3y. And it's not in order, so I'm going to go ahead and rewrite that in order. So I'm going to have y squared minus 3y. Negative 13 and 3 makes a minus 10 over y squared minus 25. Now I'm ready to factor. So I would have a y minus 5 and a y plus 2 because negative 5 times 2 is negative 10. Negative 5 plus 2 gives me the negative 3 I need in the middle over difference of squares. So y plus 5, y minus 5. I'm going to cancel out my like terms, so y minus 5 cancels, leaving me with y plus 2 over y plus 5. So that's my simplified answer. Again, if I was solving, the extraneous solution would be negative 5 because that would make my denominator 0. So I just want to kind of touch base on a few of these problems, all right? So when we look at these problems, I want you to kind of think about our steps. All right, so our steps was if we had a common denominator, we wanted to keep that common denominator. And then when we were looking at the numerator, we combined our like terms. You do have to be watchful, all right, with subtraction problems because on these examples, we had only one term being subtracted. But if I look at this, how it has a minus 8, if this had said like 8 plus 3x or something like that, I would have to distribute the negative to the 8 and the negative to whatever else followed it. So just make sure that if you have a subtraction that you are distributing that negative because that will kind of throw you off a little bit and it didn't pop up in any of these specific examples. So we keep the denominator, we combine our like terms in the numerator, and then if you can factor, you factor anything that's factorable to see if you can simplify it. If you can simplify and cancel things out, you want to do that. And then whatever you're left with, that is your final solution.